Yeah. So in the last class, we had a very simple Lindo program. Okay, so I will just show you. So can you tell me what was the objective function and all that we had written? So for all of you, you can just do this with me simultaneously. Okay. So open Google Colab, open a new notebook. Once all of you are done, then I'll proceed. Okay, so let me name this as optimization in Groupie.
So in case you are sharing something that is not visible.
Is it not visible? Because it's visible on all of my...
It's not visible. I think it is the same situation.
Divyanshu, Sajid, can you confirm?
Yes, it is visible.
Ma'am, it's visible on my screen.
Yeah, yeah. So, what you can do, sir, is maybe you can refer to the recording later on, because last time also when I checked the video, it and my screen was visible. Can you please join again once and check?
Sure, sure.
Yeah. Yeah. So I will just for those who had not attended yesterday's class, I will just write the objective function. Okay. So Divyanshu, can you tell me what was the program that we had written in the last class?
Yes, ma'am.
Yeah, please tell me.
So first of all, it would be max.
30.
Your 30 ND,
Yeah.
then plus 25, no, plus 16 NC,
Okay.
plus 25 NB for
Okay.
bookcases.
Okay.
Then we will write our constraints
Yeah.
with subject to, first we will write subject to.
That's okay.
Yes. Then in the next line, first constraint regarding your man hours, that would be,
Okay, I'll just write it. No
let me
problem. No
refer the
problem.
question.
I got it. I got it. No problem. I'll just write it. And what was the optimal solution that we were getting? Any idea? As much as I remember, it was something like 3947.37. Anyway, we'll check.
Yes.
So, yeah. So, for those of you who had not attended last class, so this is basically a profit maximization linear program for a manufacturer, where ND stands for the number of desks, NC stands for the number of chairs, and NB stands for the number of bookcases. So here he was basically trying to maximize the profits. As you can see, 30, 16, and 25 are the profits associated with manufacturing each of these products. Okay. And the first one was, I think, some machine hours constraint. Mm, First one was a machine hour constraint, where basically desks require zero point 0.8 machine hours, chairs require 0.4 machine hours, and the total available machine hours was 100. Similarly, the second one was an available man hours constraint for painting and polishing, and the last one was storage capacity constraint. And we had basically solved this in a very simple uh, software, which is known as Lindo. Okay, which is known as Lindo. So Lindo stands for Linear Discrete Optimizer. Linear Discrete Optimizer. So for all of you, what you can do is you can simply go right download Lindo. Okay, in the first uh, search result only, you will have this page of downloads. You can simply go to download classic Lindo and then just download the software. Okay. The only problem is, since you will be getting a trial version if you're not associated with any sort of institute or anything. So in the trial version, you will be allowed only up to specifying 300 variables and 150 constraints. So what we are doing today is we are simply going to do it in Python. I have chosen Google Colab because Google Colab is like very easy to use. Okay, instead of your Jupyter and Anaconda and everything, you can simply write anything and everything. Everything will work here. Okay. Okay. So now we'll start. So do it with me. Okay, so that you understand. So the first thing that we do is we install a package. Okay. And how do we install a package? We basically write pip install Gurobi Pi. Now, if you were doing it in Jupyter, then only one time you would have to write this command, and then later on you wouldn't have to do anything about it. But since we are doing it in Google Colab, and since Google Colab doesn't store anything, so okay, in its memory, everything gets refreshed once you restart the session. So every time you open Google Colab, like, let's say you have shut down your system and then you open Google Colab, you will have to keep writing this command. Okay. So have all of you installed this?
Can you tell me what is the package Guruvi?
Gurobi Pi.
Yes. Can you tell me that? Like NumPy, Pandas, we know for data analysis. So
Yeah,
what is
Gurobi
this
is
new?
mainly for optimization, usually used for all kinds of optimization, your convex optimization, LP, ILP, MILP, even can handle NLP, nonlinear programs. Okay,
Oh,
so Gurobi is a very famous solver. I don't use Gurobi, but just for the sake of the class, since it's a very easy peasy problem that we wrote here. So I'm just showing the utilization of Gurobi. What I use is Pulp that I'll show you in the next class. Today also I will give you a brief about Pulp. So Pulp can
oh,
also handle all kinds of linear programs, but Pulp I am not sure if we can handle non-linear programs. Gurobi can do that. Gurobi is a very flexible and a very famous solver in Python. Okay.
so, so it is for linear optimization for solving.
Pulp, mostly for linear optimization. Yeah.
Oh,
Gurubi is for everything. Any kind of convex optimization you want to do. Okay. So once you have done this, now step one. Okay. Step one, we will import the Gurubi Pi package. Okay. For example, any kind of program that you write, you basically import, right? So from Gurubi Pi, import everything. So we'll use star. Okay, keep doing it with me. This is the first thing first, we need to import the package. Okay. Now, after importing the package, we create an optimization model. Okay. So you can give a name to this model. Okay. It is not necessary, but it is better to always give a name. So let's say I want to give profit name. Profit mod is equal to model name equal to, let's say I want to write linear programming. Okay. So initially you are just giving the model name. Okay. Initially, this is also known as a model constructor. Initially, you are not specifying any kind of variables or constraints. Okay. Now, step 3 is you add the decision variables. Okay. And what is the syntax of that? So you basically write, I'm just telling you, model dot add where. Okay. Remember, we So see, if you, for example, here I have already written ADD VAR, and the moment I put a bracket, see, it is already telling me what all I have to specify, okay? So LB stands for the lower bound. And you know, for the non-negativity restrictions, all the values of the decision variables have to be greater than equal to 0, minimum. So you can specify LB is 0. UB is the upper bound. Okay, you do not really need to specify upper bound because mostly in any normal linear program also, it is very implicit that your UB is infinity. Okay, but still if you want to mention, I will just write how you write that. OBJ float is the objective coefficient. You do not really need to specify the coefficients here. Okay, you can simply just add the decision variables because anyway we will be defining the objective function later. So you don't really need to write the objective coefficient. Okay. V type, which is a variable type, this is very, very important. So default is grb dot continuous. Okay, in case even if you do not specify, it will take it up. But a lot of times your decision variables may also be binary. Okay, so at that time you will have to write grb dot binary. Name is the variable name. Okay, default is no name, but in order for your better understanding, you can always put up a variable name. So we'll give a variable name, and column coefficients are not really necessary. So you can see that the column and the upper bound, okay, they do not really need to be specified. So still we will do it. So I will just write. So my first variable is ND. Okay. So ND I will write profit mod, since this is my model. Profit mod dot add where. Okay. See, it has already given me everything because the moment I clicked on tab, it gave. How you can write is LB is equal to 0. Okay. Upper bound you can mention or not mention. How we write it as float infinity. Okay. And variable type, it is better you write the entire thing grb dot continuous. Okay. Name equal to ND. Same thing I will repeat for all the other decision variables.
Can you tell me when to use grb dot continuous and grb dot binary?
Okay, so grb.binary we use only when your decision variable can be 0 or 1 as the name suggests. Okay, if you see this
Yes.
model, okay, here
Yes.
actually we have all non-negativity restrictions. So ND, NB and NC can be greater than equal to 0. That's it, right? Because your
This
number
is the
of desks, yeah, tell me.
this is the constant, right?
Yes, exactly. So
Oh,
these can be anything basically. Okay. So, but at times, when, for example, you have to make a decision of whether to open a specific facility in a location or not. So, those times, your decision variable would be either 1 or 0. So, it would be 1. Let's say if you're opening a facility, it would be 0 otherwise. So at that
oh.
time, you will have to specify grb.binary. Okay. Otherwise, simply grb.continuous. Mostly we use grb.continuous. Divyanshu, are you following? Are you getting?
Ma'am, I was just typing the syntax right now. I was one
Okay.
on that third number line. So,
Sure,
ma'am,
sure.
writing after writing each line, we have to run the system, right? Run all,
Not
and then we will.
exactly. No, no, no. See, you can simply write the entire thing and then just run it all together. Okay. Why
Okay,
I do it like this is because when you will be writing very complex models, let's say you're just doing normal coding also, right? Splitting the cells always helps you to debug. Okay, otherwise, what happens is, let's say that, I have written the entire thing in one cell itself, and then some error comes up. Then I don't know that where exactly the error has happened. So this I specifically do, this is my choice because let's say it's an iterative program that I have written. And in some iteration, let's say it's throwing me an error, then it is very difficult for me to go back and see in which iteration it is happening. So I usually split the cells and run it.
ma'am, because when I have written this profit mod is equal to model name, that
Hmm.
one, the third line, I
Hmm.
haven't gotten this note that restricted license. or
Okay, no
non-production?
problem. No problem.
Okay, okay,
That's
okay,
fine. As long as your this thing is tick marked, okay, it works.
okay.
Yeah, yeah, yeah. Okay. So as you see, for the decision variables, we can specify the lower bounds, upper bounds, and the objective function. And we can also state the type of the variable and can give a name to our decision variable. So here we have basically defined all our variables. Okay. Now, the final step is what? Step 4. You define the objective function. Okay. So what do you do here? The syntax is model dot, remember, when you are adding constraints and when you will be adding your decision variable, okay, that would be dot add. But when you will be adding your objective function, that is dot set. Okay, dot set objective. Now see, so here basically you will have to specify two things. Okay, your expression and your sense. So expression is nothing but your desired objective function, which in our case is 30 ND plus 16 NC plus 25 NB. Sense is basically nothing. You will just have to specify whether you want to minimize or maximize. So for minimize, we use grb.minimize, but our model is a maximization problem. So we'll simply use grb.maximize. Okay. So remember the syntax. Even if you don't remember, see, the moment I just, type this bracket, this automatically comes up to help. Okay. Star args and star quarks. Does anyone know what is this? I'm just telling you because we came across this. This is not relevant to your current course, but does anyone know?
Yes, I have little understanding.
Yeah, so what are star args and double star quarks?
Star args is the Python syntax. Like during Python coding, it's required to give some iterable, I think iterable or give some list names and strings, those kinds of things to insert in this bracket. Exact
You are
definition I forget. Exact
no,
definition.
no, that's fine. Exact definition you don't need to say. So star args stands for arguments, okay? And
Yes.
star means, see, here when I said star, what I meant by this was that from this package it will import everything. Okay,
Yes.
I don't need to specify what all it will be importing. So similarly, when I'm saying here it is star args, that means, for example, let's say, okay, this is just for your additional knowledge, okay? Please, for everyone who is getting this. So let's say I have defined some function, okay? And now in that function, let's say I'm specifying that, okay, I need two values, x, y, and then some I'm adding here, that is x plus y. But what if there are many such values? Then what I do is then basically we specify star args, and in this function now you can pass, let's say, some function 10, 20, 30, 40, anything. It will automatically sum up all these numbers. Okay, so you don't need to exactly specify what all you are passing into your function. That is the beauty of star args. You can literally pass it as a tuple of arguments and then it will automatically take all the values, everything. Whereas for double star quarks, that is for keyword arguments. So those are mainly used in case of dictionaries. Okay, so if you want, and if I get enough time, maybe I can brush up on the very basic Python skills that you would need. But yeah, for this optimization thingy, whatever I'll be teaching here, that is enough. Okay, you don't need to anyway build very complicated models and everything. Okay, so you see already Google Colab is very intelligent. It has already added this. Okay, profit mod dot set objective 0.8 ND plus 0.4 NC plus 0.5 into NB. But I can also make it simple. Okay, what I can do is I can simply write here that this is my objective function, and here I can specify my objective function, and here I am basically doing grb dot maximize. So we use model dot set objective to specify the objective function. Okay. Now,
So is there any number we will set grb dot maximize?
is there any number?
It will be like it is an argument. So like objective dot underscore function, we have defined this number like
Right,
some
right,
0.8 into nd this. So
right.
for what we will set for grb dot maximize?
Nothing. GRB dot maximizes basically means that you are maximizing this objective function. That's it.
Okay, so it
Yeah.
will give some output, right?
Yes, exactly. See, this is your original model. Okay. This is I wrote for your understanding because you hadn't attended yesterday's class, right? So here you are
Hmm.
basically, okay, I'm sorry. I mean, this should be okay. So your objective function is 30 ND plus 16 NC. Okay, I guess Google Colab is not so intelligent. And
25.
25 NB, right? So this is your objective function. And what I mean to say is now it will be basically maximizing this objective function.
Okay.
Okay, that's it.
Yes.
Now it is our time to add the constraints. So step 5, Malayaja, are you understanding?
Hey Rupkatha, yes, I'm
Hi.
understanding.
Yeah. So basically, we are just doing this Python implementation of yesterday's program because Divyanshu had said he wanted to know how it works out in Python. So now we would be adding the constraints. So as I specified, please remember when you are adding your decision variables or adding your constraints, okay, you basically do dot add, then var, or for constraints you do add constr. So I will show you here. See. So this is your purpose is adding a constraint to the model. Okay, TC is exactly nothing. It is like your constraint, exact constraint that you are giving. Okay. And the name is you can give a constraint name. Okay. For your understanding, you can choose not to give or you can give because, see, this is a very simple problem. Again, I'm repeating, you have just three kinds of constraints and very simple constraints. But in real life scenario, when you will be solving a model, you will come across huge number of constraints. Okay, let's say they might be at the max, let's say 20, 25, and you might get very puzzled, okay, that which constraint I have to choose. So in those cases, adding a name always helps, okay. And anyway, see all these comments also that I'm adding. Once you become a pro, you really don't need to add all these constraints. But it's always good to write a kind of program which your friend will also understand. Okay. So let's say for the time being, I just write C1. Okay. Profitmore.add. See, now it has taken. Okay. So adding constraint, my first was 0.8 ND plus 0.4 NC plus 0.5 NB. That would be less than equal to 100. Name is C1. So likewise, I add the other two constraints. So here it was 5 ND plus 3 NC plus 3 NB less than equal to 650. Okay. And your constraint name is C2. And my final constraint C3 is ND plus 0.7 NC plus 1.1 NB less than equal to 140. So now your model is ready. Now, if you see, when we write a linear program, we always specify the non-negativity restrictions, right? But here you don't need to do it. Can you tell me why? Can anyone tell me why we don't need to add any non-negativity restrictions here?
because we are solving the optimization problem for maximization the
No,
objective function.
no. That doesn't mean anything. You can always choose to specify. Okay, I will give you a hint. We have already specified. Where? Can anyone tell me? Where have we already specified that my decision variables are going to be non-negative?
Lower limit bound to 0.
Exactly. See, here. Here we have already specified that L be 0. So we really don't need to do anything extra about this. Okay. So remember, we have already added the non-negativity constraints when we define the decision variables. Okay. And now your step 6 is the final step. We are now ready to solve the model. Okay. So what we write here? Profit mod, see everything is coming up, dot optimize. Okay. And another thing which I won't be doing here, you can also write the model to a file. Okay. So basically you see, this is how you do it, write file name. Okay. So it will give you the output of the LP file of the model. I won't be doing this here. Okay, but you can always do it. Okay, so in that case, you will have to write profit mod dot write and then you give some name. Okay, let's say some linear model dot LP. Okay, but it's not required here. And now you see 3.947368 into 10 to the power 3, which was, see, I don't even remember, but it's almost same, right? It was giving me 3947.37. It is giving me 3947.368, which is the same thing. Okay. Do you see? Have all of you gotten this result?
Ma'am, please show the syntax I was writing it once.
Yeah. Sure, sure.
Rupkata, can you scroll slightly up again?
Yeah, sure.
Yes, this is enough. Cell 4 onwards, you don't need to show before. Thank you.
Okay. So just tell me if all of you have gotten the same result. So Divyanshu, Malayaja, Sajib, have you gotten this result?
I'm still writing the code.
Okay, sure,
For that,
sure,
2 minutes.
sure. Okay.
Yes, ma'am. Got the result.
Okay, perfect. But if you see here, like a lot of thing is written as part of the Gurubi optimizer version. Okay, then what is your thread count? How they have optimized the model? What are the coefficient statistics? Okay, see, you don't need all this. What you need is you need basically your output. Okay, even though you can understand from your optimal objective, but still you just simply need the output. Okay, so what I'll do is step 7. Okay, output the result. So here what I can write is print, okay, objective function value, okay, that is basically profit mod dot obj val. Okay, so, okay. Yes, this is not required. See, now you're getting your objective function value. Just see if we can do something about this. And this is not required. Okay, let me not make it very complicated for you. Huh, that's it. You can simply print your objective function value is profit mod, whatever your model name you had specified, dot obj val, where v is in caps. Okay. And now, if you want to print out your decision variables, then you can write for dv in profit mod dot get vars. Okay. Print. See, this thing that I'm going to write, okay, this is not really money for your, what should I say? You can avoid writing this or not. So this I'm just doing in order to give an output in a better formatting. Okay. We'll see if this is coming or else we'll just skip. dv dot var name dv dot x. Okay, I think it's not exactly coming. I don't know. Okay. Now percentage S is for, can anyone tell me? What does this mean?
String.
Yes, exactly. So it is a string placeholder that I've used, okay? In case you're not even writing this, okay? Like this, I'll just show. See, you will still be getting the values. Okay, anyway, this came out as tuples because I specified like this. But what I wanted to do was I wanted a better representation of the same. So what I did is, see, your string placeholder, so that is dv.var name, okay? And percentage G is nothing but your floating point number placeholder. So it is taking the value of dv.x. And if you compare it with the Lindo output that we had gotten in the earlier class, it is the same.
Rupkatha, I have a question.
Yeah, sure.
Sorry for joining late, so I don't know if you've already covered this or not. At the very top, when we initialize the model,
Yeah.
there is a line that says restricted license for
Yeah.
non-production.
Yeah. Are you getting that?
Yes.
Ah, okay. That's no problem. I mean, I think Divyanshu had said he did not get that, but that's no problem. I mean, it's fine.
Sure. What does it mean? As in, is it because one has
Because
to
we're
purchase a Gurobi license usually?
no. So what is happening is, see, you're using Gurubi license just like that, okay? Usually, see, I was showing it in Google Colab so that all of you can do. Otherwise, if I ask you to download Jupyter or download some, let's say Anaconda Navigator and everything, and then install Gurobi Pi in the terminal, then all this won't come up. Because, for example, I personally have an academic license of Gurobi. Okay. So that will never show me this expiration date. But in Google Colab, for a lot of packages which you might use on and off, this kind of thing will show up. And also another thing is that I had mentioned this at the very beginning of the class. So let's say I wrote here, pip install Gurobi Pi. Now Google Colab won't be storing this. So every time you open Google Colab, like a new notebook, you will have to write this. But had it been on your system, once you have specified this, then never ever would you have to write this again because it is already installed. So in your own Jupyter notebook, if you run this program, it will say requirement is already satisfied. But since this is like collab environment, this thing shows up, but that's no problem.
Sure. So the expiration date will not be an issue if I were to do this in my local computer.
Nothing.
But you mentioned that you have a academic license.
Yeah, in my own system.
Right. So I wouldn't need a license to use Gurobi?
No. But if you want to use it on your system personally, then it is always better to have a license. Okay, and in case you want to know how to install and everything, I will tell you maybe next week or so. Okay, that's no problem. Okay, like how to install Gurobi and Gurobi Pi. Okay, but the only thing is why I avoid is it's very hectic, and for your general purpose use, like mostly I use Google Colab. It is fast. Okay, for example, here this system that I'm using is a MacBook, so that's not an issue for me. But when I was using Windows, my RAM was not enough to support a lot of complicated models that I was solving. So here you can see in Google Colab, you can always what should I say? Change your runtime type. Okay, you can also use T4 GPU, okay, which is like faster than CPU. So for faster processing and all, I think Google Colab does your work pretty well. So this is why I always prefer using Google Colab.
Sure.
Okay. Okay, so Divyanshu, I hope you are clear with how we are doing it in Python.
Yes, ma'am.
Okay, so do you want to maybe solve another program just like that in Python, or we can move to our teaching stuff? Because I
Ma'am,
want,
you can
yeah.
just share a problem. You can share a problem. I will try it on my own.
Okay, that works good. Okay, fine. So this is a
Yeah.
homework for you all. Okay. So what I will be giving to you is, so you basically have to use Gurobi and report to me in the next class. Okay. So this is your homework. And this homework that I'm giving, that is a mixed integer linear program. Please remember. So in a mixed integer linear program, what it means is that some of your values might be simply integer and some of your values might be continuous. Okay. So for example, let's say I forgot the syntax for this, but does it work? I just wanted to see. Yeah, okay. So there are three things which I wanted to specify, right? If it is a pure integer variable, you specify grb.integer. Okay. If it is a pure binary variable, then you specify grb.binary. And if it is a continuous variable, just like this, you specify grb.continuous. Okay. So this is the only thing which you will have to take care. So what you will try to do is you try to,
Mm,
yeah, tell me.
Ma'am, please repeat.
Yeah.
GRB dot binary for.
Binary for your decision variables, assuming only 0 or 1 values. Okay. If it is only 0 or 1, then it is grb.binary. See, here, okay, let's not complicate. You can also write B. Simply B you can write. But don't. For your sake, just write grb.binary. Okay. If it is an integer variable, pure integer variable, that is, it can assume only integer values, then you specify grb.integer. You can also write simple I. Okay, then it is grb.integer. And if it is a continuous variable, just like this, okay, where nothing is specified, only it has to be greater than equal to 0, then it is grb.continuous or C. So if you want, I can solve this mixed integer linear program right now, or else if you want to do it as a homework, I don't have any issues. That is your call. Whatever you guys say.
Ma'am, will the syntax be much more like similar to this one, or it might have some
Exactly similar to
difference?
this one, only your decision variable values, I mean, the type of the decision variables would change.
So I have a query at this point that while
Yeah,
adding the decision variables,
yeah.
why are we repeating the same names like let's say name is equal to ND or name is equal to NC? So is there any other purpose of reassigning or giving a name here? Because we have already assigned the return type to return value to the variables ND, NC, and NB.
Yeah, there is no problem. You can always choose not to give a name here. Okay, this is just, like to show. See, even if you don't give this, okay, the model is not going to be affected. This is just your call whether to give or not. I do it because I like writing things completely. Okay, because a lot of time, what happens is, for example, here I wrote ND, NC, NB. Okay, a lot of time people don't write it. They will just write ABC. And then here they will specify the names like big number of desks, number of chairs, like that. Okay, here anyway I had taken the short form. Let's say you have a lot of decision variables. Okay, you won't have the time to give them abbreviations, so just simply write A B C D E F G H, but here you will mention. So whenever something is happening later on in your code, you can always go back and see, okay, this first decision variable referred to this one. Okay, that is the sole purpose of the name. Even if you don't give it, that's not a problem.
Okay. And
Yeah,
then in the cell number 8, wherein you are optimizing or solving the model,
yeah.
so do we have the liberty to select the optimizer, or do we have some option to know that which optimizer was used in the background for any solving this?
Yeah. You can always do that. I mean, I'm not really sure about Gurobi. I guess you have, because in Gurobi there is not any particular solver as such that, it automatically takes up what kind of solver it will use based on your model. So as for this one, I'm not exactly sure if you can specify, but in Pulp, for example, you can specify which solver you need. There are solvers like Coin, CBC. So you simply write it here, like that what is the kind of solver that you need. But in Gurubi, usually it's not needed. But still, I mean, I'll check if you have to specify. You don't really need to specify, but mm,
Rupkatha, you mentioned in which thing do we specify the optimizer? I didn't catch that word.
here. So as he was asking that whether we can specify any sort of solver that you can use. Okay, so
So,
in Pulp there is an option like that.
what
In
is pulp?
Gurubi, Pulp is another module in Python which I primarily use for solving my linear programming models, because the models that I have built were mostly LP. Okay, but
This is
I,
PULP, pulp.
yeah, only LP, LP, MILP.
I
Okay,
see.
Pulp,
That's what
Pulp.
the LP at the end of pulp stands for.
But for non-linear programming, quadratic programming, you cannot solve it in Pulp. You need Gurobi for that. Okay, so Gurobi is actually like it employs very advanced algorithms. Like for example, your see mostly for if in integer programs we use a kind of algorithm like branch and bound, but Gurobi would employ branch and cut. So yeah, as much as I can see, you cannot really specify any optimizer in Gurobi because it takes care of everything on its own. Okay, but I'll still go and check if there is any such specification required in Gurobi. I mean, it is not usually, so we don't.
Could you also share names of some other Python libraries that are often used in optimization? So we've looked at Gurobi and you've mentioned pulp. Are there any
Mainly,
others?
mainly Pul and Gurobi for Python based. For non-Python based, like there are softwares like legit softwares. I don't know. Okay. For legit softwares, you have like Cplex, GAMS, AMPL. But before all this, you need data processing, data pre-processing. So for data pre-processing, a lot of people use LlamaSoft, Alteryx. Okay, because like some of you might be coming from industries and it's something you already know. So data is not very clean when it comes to, like your real life scenarios. So data pre-processing is a huge task then to get a proper to get a proper processed clean data out of your raw data. You need to do a lot of pre-processing. So those pre-processing sometimes you can do in Excel itself, or you can use SQL. Okay, or a lot of such platforms are there. So first thing first, we use data pre-processing, and then you can use your optimization solver and then simply put in the values. Okay, for example, this was a very simple problem. But in cases, let's say, where there is an Excel file, then you have to read the Excel file, read the data from that Excel file. So there we do something, we use data frames, right? Like pandas, import pandas as PD. And then we write pd.read hyphen Excel underscore Excel. And then we read the Excel file, we get the data from there. Okay. So such things, like
Can you
there,
can you
yeah.
please tell me that how like text preprocessing is connected with this optimization problem?
So see, for
Where
example, yeah,
like text
yeah,
preprocessing is another thing and optimization is another thing. So how
right.
these
Abs
those things
abs
are connected?
Absolutely. See, if you go in like a proper industry-based scenario, like when I was giving my interviews before this, what I realized is in academia, we have like a lot of clean data. Okay, so either we are collecting some data from some government reports, or we are collecting data from some published research papers. And what we are
Mm.
doing is, okay, we are simply importing the data in an Excel file, and from there we are just reading it. But in
Yeah.
industry, a lot of raw data comes, okay, and they are not necessarily understandable to your system. So data pre-processing means you have to do a lot of data cleaning, data manipulation, okay. Now that is completely another branch. For example, let's say you have collected data for some organization from the financial years 2009 to 10 till 2019 to 20, but some of that data is missing. Okay, now you don't know what to do, right? So what you do is then you do something known as EDA, exploratory data analysis,
Yeah.
okay, where you
Mm.
basically try to find out the trends between, let's say, two variables. If it is linear, you are using one kind of imputation. If it is non-linear, then maybe you are using something known as MICE, multivariate imputation by chained equations. So a
Mm.
lot of such missing data techniques are there. Then a lot of times you will have to see whether there are any duplicate values. So after a lot of data cleaning and manipulation and everything, then you finally arrive at, let's say, a clean balanced data set. Okay, so
Mm.
mostly, see, optimization these days a lot of people can do. And I feel that these days with the with this rise in large language models and everything, in fact coding is
Mm.
also not a bigger issue. You go
Mm.
out there, you simply specify to your LLM model, okay, maybe Claude or Gemini Pro, that okay, this is what I want in Python, just write me a code. They will instantly generate the code. What matters, why I was specifying on the very first day of this class that why the human component is needed, is because we need to assess the data. We need to know what we want, because often, let's say you have you want a code to be written, and
Yeah.
your your chat gpt has given you the model as well, and it is working perfectly fine. But when you go out there and you implement it in the real life scenario, you might see that the optimal solution doesn't even make sense. So there, what has happened? So for example, let's say you have had some missing data, okay, and you
Mm.
ask your chat gpt that okay, what do I do? It will say okay, fine, let me do this complete case analysis. What complete case analysis means is completely remove the row. But at times, you might know that okay, if I completely remove that row because that row has no data, that might not give me right results at the end. So you might go back to your manager or your boss and you can say that, okay, we cannot work on this. That is something we have to specify to the client. So that is why in any kind of optimization world, data is very important. And I think for this, the very basic things like data engineers come into play, where they specify, where they are responsible for the end-to-end for designing the end-to-end pipeline, for giving you the right data, because ultimately, see, there is no end to learning. Okay, this is simple operations research. Today people are clubbing it with machine learning. Not even machine learning, people have gone way beyond deep learning, reinforcement learning. And if you go to any good platforms, any YouTube, you will learn this very easily. Okay, it is very easy to learn all this optimization and everything. But what is not easy and what is still an obstacle in today's world is, how do I get my data? Because data is incredible. It is huge. Every business is producing incredible amounts of data. You get so much data from call centers, but they are completely raw. You don't know what to pick and what not to pick. Simply, you can't apply a regression model and say, okay, these variables are significant, so this I'll pick. You also need that human component to analyze that even if this variable is not significant according to my mathematical techniques, but I need this. So this is where it comes into picture, and that is how data pre-processing is, linked to optimization. So I hope I was able to clarify.
Yes,
Yeah,
yes, yes. And one thing, when you build this optimization function, so how you
right.
get those numbers like zero point 0.8 or how you build this constant?
Okay, right. So this one was actually from a, so I will be solving some of the case studies today. I have taken 6 of them. If you people are energetic enough to stay with me for 1 hour or more, I will see how many I can solve. So this was already specified in the question that,
Oh,
okay, the profit associated with producing the number of desks is 30 rupees. Associated with number of chairs is 16 rupees. So already this data you will be getting from your case study or whatever is your business scenario. Okay, so all this was
okay. So
specified. This was not, yeah,
according to that data set, or I will build this constant like
right,
zero point 0.8 into 8 ND greater than
right,
100. Like,
right. Absolutely.
okay, and one thing, you have write that grb dot integer and grb dot continuous. When
Right.
greater or equal to 0, then we will face the continuous, right?
Yeah. Simply when it's greater than equal to 0, you write grb dot continuous.
But if it is 8 or 10, then I will write integer.
Then you don't even need to specify. See, LB will be anyway 0 for your grb dot
Mm,
integer. But if your grb is binary, then you don't need to specify anything because either it can be 0 or 1. Okay, you don't need to
sure.
specify any. In fact, you don't even need to specify the upper bound. You can just ignore this. Even in this problem as well, you did not need to specify the upper bounds. Yeah, you can just ignore. Okay, so you want me to give you a homework then? You want to try this out later on? Does that work for all of you?
Yes, sure.
Sure. So, your new model is, okay, this is simply just a random model that I'm giving. Maximize 2x plus y plus 3z subject to x plus 2y plus z less than equal to 4, 2z plus y less than equal to 5, x plus y greater than equal to 1, where x can be only 0 or 1, that is, it is a binary variable. Okay. Y and z are greater than equal to 0, and z can only be an integer. Okay. Please note it down and solve it. I mean, in next class, you can tell me.
Is it possible to share the notebook in our chat box?
Sure. I'll
To,
just do it.
because so that we can remember what is the homework.
Sure. I'll just do it now. Mhm. Yeah, I hope all of you have gotten this.
Yes, yes.
Okay, so I will stop sharing from this one. Okay, let us solve a problem today. So I will just share my screen from here. Okay, this is your problem for today. Just take a snapshot of this problem. Read the problem for a while and then we'll solve. And I hope all of you are understanding whatever I'm teaching. In case you are having any doubts, please feel free to poke. That is why this is a live class and this is not a recorded lecture for at least those of you who are attending. So today we did the Python implementation of last class's problem. And from now onwards, I want you to have a hands-on feel of how to solve these LP problems, and then we will jump into the theory side of it the moment this gets over. So have all of you taken a snapshot?
Yes.
Yeah, perfect. So read the problem and I'll give you 2 more minutes. At 9:39, we'll start solving the problem. Okay, so have all of you read the problem? Any answers?
Yes, ma'am. Read the question.
Okay, fine. So, what is it saying? Can you tell me?
Ma'am, the capacity and demands of three products are given.
Right, very good. And what is
The
expected?
capacities are given.
Yeah, tell me.
We are also given the production rates of of the three products.
Right. So, okay, can you see my screen? Can you see my writing?
Yes, ma'am.
Yes.
Perfect. Okay. So this is a product mix problem. Okay. And as I was specifying in the earlier class, before jumping into solving a mathematical model, the first thing first that you have to do is always write a verbal formulation. It just makes things easier, right? So in the verbal formulation, the first thing that we do is we specify what are our decision variables. Okay. So what are our decision variables? Can you tell me?
Production
Man hours
capacity.
available,
No.
production
Huh?
capacity,
No. Okay. Before this, you had said something. What did you say?
man hours
Hours, man hours of what?
of all the factories A, B, and C.
No. See, first tell me what is the objective in this problem? What is that you are trying to achieve? Okay. If you understand what it is that you are trying to achieve, only then will you be able to formulate this model correctly. So what you're trying to achieve is you are trying to determine the optimum product mix. That means you are trying to understand how much of product 1 or product 2 or product 3 has to be produced, right? Am I clear? And at the same time, you have 3 plants. So your decision variables are, let's say Q1A, that is the quantity of product 1 to be produced in plant A. The unit is in number of pieces, let's say. Similarly, quantity of product 1 to be produced in plant B. Quantity of product 1 to be produced in plant C. Likewise, you will also have quantity of product 2 and product 3.
So is there total 9 constraints for this?
9 decision variables
Yes.
as of now. Is the decision variables part clear?
Yes.
Yes, ma'am.
Yes, clear.
So after this, what is the next thing that you will have to do? You
Constraints.
will, right. So now, when I talk about constraints, what are the constraints?
Production capacity.
Hours available in each factory, then
No,
your
not hours
demand.
available. Not hours available. See, okay, just a quick hint, not really. So this problem can be formulated in 2 ways, and I'll show you in 2 ways only. Okay, but that change would be in the number of in the way you specify your decision variables. Okay, so the thing that you are going on about the hours available, that is not really hours available, that is hours to be spent for producing product 1 in plant A, and that becomes your decision variable. So as Ayush was saying, one constraint is plant capacity constraints.
Demand also.
Yes, absolutely. Plant capacity constraints. And the second is your demand constraints. Okay. What is your objective function?
Optimum product mix.
No. See, always remember in your objective function, you are either maximizing or minimizing. So what will you try to do here? Read the problem
Maximize.
again, Divyansh.
Minim
Okay, good. Maximize. Yeah, Divyansh should tell me why minimize. Minimize what?
ma'am, production costs. That was
Do you only have the production cost specified in the question?
no, ma'am. We have selling price and
So
maximizing selling price would be much better.
no, maximize selling price minus production cost, right? So you're basically maximizing profit, which is nothing but the sales revenue minus production cost. Okay,
Yes, ma'am.
got it? No doubt, right? And the final is your non-negativity. Okay, so in your non-negativity, all the decision variables would be greater than equal to 0. So this is your verbal formulation. Now, okay, I will just. Now, if I have to do, okay, I'll do it here itself. If I have to formulate this mathematical model, then how do I do it? First, tell me in terms of constraints. Okay. First, consider only the demand constraints. Now, what is mentioned in the question? That the demand are 1,000, 2,000 and 3,000 pieces respectively for products 1, 2 and 3. So how will you write the constraint? Can anyone say other than Ayush and Divyanshu? Malayaja, can you give it a try? So the first thing that we do is we will write for demand constraints. Sajid, can you try?
Yes, I'm just taking.
Ayush?
And what is MM?
Mathematical model.
Okay.
Yeah. How will you write the first
Ma'am,
demand constraint? Yeah.
this objective function which we have written maximizing profit equals to sales revenue minus production cost.
Right?
We can, like he was saying that to minimize the cost. So can we also write this like in minimizing loss?
No. I mean, okay. Do you want to write minimize production cost minus sales revenue?
Okay, that will be the same thing. You got it, ma'am.
Same thing, same thing. Yeah.
So earlier we have seen that some variable like X, Y, Z. So
Right.
there is no variable name like this. It is only 1, 2, 3 or ABC. So how
No,
we
it is
can write?
Q1A, Q1B, Q1C, Q2A, Q2B, Q2C, Q3A, Q3B, Q3C.
Okay, okay,
Yeah.
okay.
Yeah, Divyanshu, if I have to write the first constraint for product 1, whose demand has to be 1,000, how do I write it?
Ma'am, then it would be your mm, product one. Then it would be, ma'am, like because you have 4 hours are taken at plant A particularly
No, no, no,
for
no, no.
production.
No, no, no. See, I have not
Q1A
even
plus
touched that part. Okay, just see the
Q1A plus
decision variable.
Q1
Exactly. Q1A plus Q1B
plus Q1B plus
plus
Q1C.
Q1C has to be greater
Plus
than equal to
means
1,000. That's it,
yes, yes,
right? Same thing you will
yes, ma'am.
have to do for product 2 as well. Q2A plus Q2B plus Q2C has to be greater than equal to 2,000. Similarly, Q3A plus Q3B plus Q3C would be greater than equal to 3000. Right? So altogether, these are your demand constraints. Now I want to write my plant capacity constraints. So here that fourth thing that you were saying would play into part, but how? What is the statement for capacity constraints? Can anyone tell me?
It
Malaja?
cannot be greater than that.
It cannot be?
Greater than that.
I didn't get you. Cannot be greater than what?
The capacity, the production capacity of the 3 plants.
Yeah. I'm just saying, what is the statement in your question which states about the production capacities and what does it say?
It is 500, 800, and 700
Absolutely.
hours.
Right. So whatever comes here, okay. So for your product A, it would be less than equal to 500, product B less than equal to 800, product C less than equal to 700. Now let's say I want to write my constraint for product A. How will I write it?
Four Q1A
Hmm?
plus 6 Q1B
Hmm?
plus 5 Q1C
Hmm?
should be less than equal to 500.
You are almost right. There is just a problem here. Can anyone tell me what is the problem?
It should be 3 Q2A and 2 Q3A, right?
No, we are only talking about product 1. So he's right. See, for product 1, the production rates per hour at plant A, B, and C are 4, 6, and 5. I'm just saying there is a problem in this constraint. A very simple problem, which is why I taught you in the very first class that when writing constraints or writing your decision variable, something else has to be taken care of. Do you remember what had I said?
The units.
Exactly. Now here the problem is of the units. Can anyone identify how before I say where is the problem with the units?
Because 500 is in hours and your number and the other units are in number of pieces per hour. That's why.
See, almost close. Okay. Since you have only specified, I'll like give it back to you. So if you see Q1A, what is the unit here? Number, right? It is some number of pieces. What is 4? 4 means that per hour, okay, per hour at plant A, 4 numbers of product 1 can be produced per hour. So if I have to change this, you are basically multiplying 4 numbers into some numbers by hour. Does that make any sense? No. But
No.
what if I take a reciprocal of this? I do 1 by 4. Now what that means that one number can be produced in 4 hours. Sorry, one hour will wait. Sorry. What I can write here is that in 1 hour you are producing 4 numbers of product A. And now if I multiply it with some Q1A number, that makes more sense, right? Because numbers get cut and you have hours.
Yes.
So it should be 1 by 4, 1 by 6, and 1 by 5.
I have another question.
Yeah, sure.
So A, B, and C are plants, right?
Right.
So, and we have the production capacities according to the plant. So plant A has a production capacity of 500.
Right.
So A
Okay.
can produce.
Yeah, you are right. Here he had done wrong. It should be 1 by 3 Q2A plus
Yeah.
1 by 2 Q3A. Yeah, absolutely. Thank you so much for pointing out. Yes, you are right. So I'll just write the corrected version. Yeah, absolutely. Thank you so much. So it should be 1 by 4 Q1A plus 1 by 3 Q2A plus 1 by 2 Q3A less than equal to 500. Is that clear?
Yeah.
Yeah. Divyanshu, you
This
got
is,
it? Where your problem? Yeah, Sajid, please tell me.
Yes,
this is
yes.
for product. This is for production one, right?
This is for production at
Product.
plant A,
Sorry, yes. For
right?
plant A, we have three production, like 1, 2, 3. So
Right,
that is the
right,
variable.
right, right, right. So you take 1 by 4, so you take column wise. Ayush, clear? Okay. Anyway, same thing you will also write for plant B. So plant B, how will you write?
It'll be 1 by, the coefficients will be 1 by 6, 1 by 4, 1 by 3. And on the right hand side, it will be less than equal to 800.
Absolutely. Okay. And the same thing would be oh, sorry, this should be 700, I guess. Okay, so now I have written down my demand constraints and capacity constraints both. So now what is left? Objective function. Okay, so for the objective function, I will break it down for simplified. So we have max profit, which is nothing but the difference between your sales revenue and the production cost, right? So what will be your sales revenue? How will you write it? What is the statement in your question?
50 Q,
Yeah,
50 times Q1A plus Q2A plus Q3A. I can
Q1B.
find the
Q1B.
50 rupees is the selling price of
Products,
product 1.
right? Yeah, very good. Yes.
Oh, right, correct, you're right.
So 40 Q2A, Q2B plus
Mm-hmm.
Q2C plus 30 Q3A plus Q3B plus Q3C. Okay, so this is your sales revenue. What about your production cost?
The coefficients will be 10, 8, and 12 respectively.
10, 8, and 12, right. But there is a slight catch.
Per hour.
Per hour, yes. So how will you write it?
So you multiply by number of hours.
No. See, here also we had done, right? Per hour. Not per hour. This was per piece, right? So if you see, this is 10 rupees per hour, right? Into 1 hour by 4 numbers into Q1A numbers. Then you see, this stays the same. R gets cut, numbers gets cut, rupees stays the same.
Got it, okay.
Right? Got it? Divyanshu, understood? All of you understood? So,
Yes, yes.
so here we just have to simply add this catch. We'll just have to write 1 by 4 Q1A plus 1 by 3 Q2A plus, because see, the production capacities, production costs are plant wise again, okay, not product wise. So Here it would be same thing, half Q3A plus 8 multiplied by 1 by 6 Q1B plus 1 by 4 Q2B plus 1 by 3 Q3B plus 12 1 by 5 Q1C plus 1 by 3 Q2C plus half Q3C. So your objective function becomes maximize. See, 50 Q1A minus 50 Q1A. Is there any Q1A here? No. Only here it is. 50 minus this is 2.5. So 50 minus 2.5 is 47.5. So 47.5 Q1A plus 50 minus some 3.6. How much is this? 3.33. So 50 minus some 3.33 would be something like 47.6, I guess. You can do the calculations. Okay, so let's say some Q1B. Okay, plus this is again. No. I'm sorry, I was wrong here.
Excuse me, ma'am.
Yeah.
Can you again explain that how that 47.5 came up?
Yeah, so 50 Q1A minus 2.5 Q1A, 47.5. See, you're basically maximizing profit, right? So you'll have to subtract your production cost from sales revenue. Okay.
Okay, got
it. Similarly, 50 Q1B. Okay, here you have a Q1B. So this is 3, 4 minus, I guess this is how much? 2, 3, 4, 1.33, right? So 50 minus some 1.33 would be 48.6 Q1B plus 50 Q1C. Again, where do you have Q1C here? Here. So this is how much? 2.4, right? So 50 minus 2.4 is 47.6 Q1C plus 40 Q2A minus some 3.33 Q2A. So let's say 3.3. So 36.7 Q2A plus 40 Q2B minus 2. So 40 minus 2 is 38. 38 Q2B plus 40 Q2C minus 4 Q2C, right? So 36 Q2C plus 30 Q3A minus 5. So that is 25 Q3A plus 30 Q3B minus some 2.6. So that would be, let's say, some 27.4 Q3B plus 30 Q3C minus 6. So 30 minus 6 is 24 Q3C. Okay. So this is your objective function.
Rupkatha, I have a question.
Yeah.
If we go back to the capacity constraints and the demand constraints,
Right.
Why do we have an inequality here? Why not an equality? Because in the question, it doesn't explicitly say that demand can be equal to or greater than blah, blah, blah. And the capacity constraints, I did not understand. Like from the question, the inequality did not seem clear to me. Could you explain that?
Sure. So in any kind of linear program, okay, when I was explaining to you the general form of an optimization model in the very first class, where did I explain? Here, right? So here I was saying it can be greater than, equal to, or less than. Why
Right.
do we specify inequality constraints? Okay, it is very simple. It is because we want to allow for a wide range of real world scenarios. If you specify equality constraints, no, it is a very strict or hard constraint. So sometimes your model might not give you an optimal solution.
Got it. So
Okay,
then why
yeah.
are we assuming that demand has a lower limit at 1,000, 2,000,
See,
3,000?
it's very simple, right? Demand is 1,000. You wouldn't want the customer to be unhappy. You wouldn't want to just deliver 900 units if you can deliver 1,000 or more than that. Like, why restrict ourselves to 1,000?
So
If
the
something is the
implicit,
demand, hmm,
so the implicit assumption is that demand can be lower bounded and production can be capped, has to be capped at
no,
whatever
not
amounts.
like that. Like, think of it as like, like coming from a very basic intuition. Suppose, let's say you are teaching, let's say you are selling some product of yours, okay? And the demand for that is 500. So you would want to meet at least that 500. You wouldn't want to sell
Got it.
lesser than what the customer wants,
Makes
right?
sense. Yeah.
So that is why greater than equal to. But in capacity, production capacities means that your machine, let's say, cannot run beyond that. Okay. There would be some breakdown failure or everything. So only till 500 hours, or if not 500, lesser than that it should run. It should not go beyond that. Okay.
Got
So
it.
that is why.
Understood.
Unless and until, like, there are very hard constraints. For example, let's say in a bus depot allocation problem, okay, let's say your bus can be allocated to only one depot. In that case, that is a perfect equality constraint. That, okay, bus, let's say there are 3 depots, okay, let's say there are some 3 depots, D1, D2, D3, and let's say you have your bus 1. Okay. And now your bus 1 can be allocated to any one depot, right? Like, that is very logical and practical. So there you will write B1 D1 plus B1 D2 plus B1 D3 strictly equal to 1. You won't write greater than equal to 1, because if you write greater than equal to 1, what if all these 3 assume values? That doesn't make any sense, right?
Right.
You won't be writing less than equal to 1, because what if none of these assume a value? Your bus has to be allocated to any one depot. So only in such special scenarios do you impose equality constraints. Otherwise, for defining your feasible region, which is basically representative of all the candidate solutions that can satisfy your problem ka constraints, you usually go for inequality constraints.
Got
Okay?
it. Understood.
Yeah, yeah. Any doubts? Anyone else? Okay, I'm assuming there are no doubts. One thing just for your fun, you can do is you can try solving this in Python. Okay, and also I will suggest you something. Okay, instead of relying on the code that I wrote, okay, always whenever you are writing anything in Python, okay, you can always check the documentation part. So in documentation part, if you see, why am I saying is because see now here, the variables, the decision variables, if you see, they're kind of related to each other. Like 1, 2, 3, or either it is A, B, and C. So either it is Q1A, Q1B, Q1C, or it's Q2A, Q2B, Q2C. So what you can do is, instead of separately defining all the decision variables, that also you do, going by the way I taught you today. But instead of separately defining the decision variables, you can also generate a for loop or something like that, which generates tuples like 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C. So that will make your problem slightly easier to understand. And then you can, like maybe write separate columns where you basically plug in these values, 1 by 4, 1 by 3, and then try solving it in Python. It will be slightly more complex than the very easy peasy program that we solved. But this is just something that you can just try it out on your own. Anyway, we'll be discussing such capstone case studies and their Python implementation in our week 7. But just for your own sake, you can try. But yeah, till then, please solve that MILP homework that I gave. Okay. So I'll move to the next question now.
I have a query here that
Yeah, sure.
so is this uncommon to have multiple objective functions in the LPs? Like, can we have the conflicting objective functions wherein one value needs to be maximized and the other one is to be minimized?
Right. So basically, for my teaching purposes, I have not considered multi-objective optimization, although I would be teaching something known as goal programming, where you will be having conflicting objectives. Okay. But there again, also ultimately, when you write the goal programming problem, it would be a single objective function because you're basically minimizing the deviational variables, although you will have a lot of conflicting objectives there. So usually not just even in just for teaching you all, even in your real life aspect, even when you go out there in the industry, mostly they would ask you to convert it into a single objective function because that makes things a lot easier. Okay, having conflicting objectives usually is solved by goal programming if you have to solve it like on a very, what should I say, on a very easy scale. But usually we go for single objective optimization because multi-objective optimization is something that you can go for when you are, like publishing some paper in some good journal. And then what you do there is you do step by step optimization. So in step one, you are maximizing something. Then whatever output you are getting from that step one, that acts as an input to the step two. And then step two, you are doing, let's say, some minimization. So there we go for step by step. But usually 95% or maybe even more than that, I would say, we always go for single objective optimization, just in order to reduce the complexity of the problem.
Okay.
Right. Okay. So our next question is this. Yeah. Please take a snapshot and I will also draw the diagram after you take us. Okay, sorry. I guess before, okay. Let's not jump from this problem. Okay, so I think I had mentioned to you, right, that there is also another way in which you can write this decision problem. Divyanshu?
Yes, ma'am.
Right. What was that I was saying? What is that one change that you can do in another way that you can write this problem? So this is your homework. This is something that you do because I will tell you what are the decision variables, but the way you will have to formulate the model that should come from your end. In this formulation, the easy thing is that your 1/4, 1/3, jo itna complexities we did in this model, no, that is not needed. Okay, so I will tell you what is the decision variable. Okay, very interesting problem actually. So in this case, the decision variable that we specify is H1A, where H1A basically means the hours to be spent for producing product 1 in plant A. And similarly, we'll have H1B, H1C, H2A, H2B, H2C, H3A, H3B, and H3C. This is another way of solving. But ultimately, even if your friend is solving like this, you will arrive at the same solution. That's the beauty. Okay, however you solve it, you will be arriving at the same solution only. Now what happens is, see, very simple difference. Here, if you see, we were multiplying with 1/4, 1/3 and half, right? Here, take the first constraint, for example. Why? Because we wanted it to be consistent with the number of hours on both left-hand side and right-hand side. Now, how can we write this constraint? Can anyone say? This is your decision variable right now. Ayush, can you try?
And will it be 4H1A? 4H1A.
Why 4H1A? Your H1A is already the hours. For H1A would be in something else. See, I'm asking you to formulate the capacity constraint. I'm asking you to formulate this one, this capacity constraint. It will be very simple. It will be nothing but H1A plus H1B plus H1C less than equal to 500. That's it.
Yes.
Hours. है ना? But Your 4H1A pata hai, where will it come? When you are writing for this one, no, your demand constraint. Now see, production rate per hour. So 4H1A plus 6H1B plus
Plus 5.
5
H1.
H1C would be greater than equal to 1000. Did you guys understand?
Yes, ma'am.
Yes.
Yeah. Yeah. So rest is your homework. Okay. You formulate the objective function. If not using Python, at least you solve this entire problem in Lindo so that you get a feel on what is the optimal solution. Okay. You solve it in Lindo. Okay. This is for sure your homework. If not, you are doing that maximization problem in Python, which I gave you as an MILP problem. Please solve this in Lindo. Please formulate this model as well. Okay, if you are not able to do it, we'll discuss it in the next class. No problem. Then you solve this one also in Lindo and check if you are getting the same optimal solution. Okay. So this is your homework.
Ma'am,
Yeah.
this is the duality, right, ma'am?
No, I have not even
Okay.
touched duality. Okay. This is a simple primal model. Both of these are primal in their own way. How come this is a dual model? Had it been a dual model, your
Yes,
objective function would have had all these values, all these right-hand side values in its objective function.
yes, ma'am.
You're not
Yes,
even
ma'am.
getting there. I'm just saying this
Yes.
is another way of, you know, solving this problem. So this is for sure your homework. Please do it. Okay. Okay. So we'll jump to the next problem. Yeah, this is your next problem. Please take a snapshot. This will be your last problem for today. Anyway, I decided to solve 6 problems, but I guess time passed very fast. So another 30 minutes will solve this problem and yeah. Once you are done doing this, okay, I think I would suggest you take 1 more minute extra and you try to make a diagram. Okay, whenever you are encountering something like this, it's always important to draw a network diagram. Okay, we call it a network diagram. So try to draw a network diagram. See, you have 2 plants. On the left hand side, you draw 2 plants, S and N. 2 major warehouses. In the middle, you draw 2 major warehouses, R and V. And the retail outlets on the right hand side, B and M. And based on the statements, you draw your arrows and write the numbers. See how much can go into one warehouse, how much can come out of one plant, how much can come out of one warehouse also, and how much can go into one retail outlet. So read the problem, take 2 to 3 minutes, draw a network diagram. If possible, share your screen and show me the diagram. If not, I will anyway do it. Okay. So take 2 to 3 minutes now. Okay, so has anyone been able to draw a diagram? Draw a network diagram?
One minute, ma'am.
Yeah, sure. Anyway, I'll draw so you can follow whichever you have drawn. So here we have the supply. Here we have the warehouse. And here we have the retail. Okay, so this is question 2. This is question 1. Okay. Supply we have S, N. Okay. Warehouse we have R, V. And here we have B and M. Okay. Now, S can go to B, S can go to R, S can go to V. Okay. N can go to R, N can go to V, N can go to M. R can also come to V, R to B, R to M, V to B, V to M, and PM and M to B as well. Okay, so how did I make this? So you see, it is said that items can be shipped. I will use something else. Yeah, black. Items can be shipped directly from S to B at a cost of 25 rupees per unit. So this is S to B, okay? Or they can be shipped from S to R at a cost of rupees 15 per unit, okay? And S to V at a cost of rupees 16 per unit. Similarly, shipments from N can go either to R at a cost of 18 per unit, to V at a cost of to V at a cost of 14. What is happening? Oh, sorry. To V at a cost of 14 per unit, or to M at rupees 30 per unit. From R, shipments can be made to either B at rupees 10 per unit, or to M at rupees 19 per unit, or to V at rupees 5 per unit. From V, shipments can be made to B at rupees 13 per unit, or to M at rupees 17 per unit. Finally, shipments may be made between B and M in either direction at rupees 9 per unit. So this is how I made the network. Got it?
Yes, ma'am.
Yes, ma'am.
Now, supply quantities at S. What is the production capacity? 40 units. So here we can write 40 units. N is 65 units. Production demand at B is 75 units. At M is 30 units. Okay. Any other detail that has been given in the question? Okay,
The
warehouses
storage
R and V.
facility.
Huh?
Yes, ma'am. The storage quantity at R&D.
Right. R and V are 50 units. 75 units. Okay. And yeah, with this, our network diagram is complete. So now the question is, what set of shipments will meet the demand at minimum cost? Formulate as in LP. So the first thing first that we'll do is what? We'll do the verbal formulation. Yes, I'll keep.
Yeah,
What happened?
I'm not able to find S2R is 15.
Just a sec. I got logged out of my system. Okay. Yeah. S2R. Why not? In the question only it is given, no?
On from S to B and S to V we can reach. S
No,
to B and
S2R
S
is also given, no, in the question.
to R. Okay.
See, right? Or they can be shipped from S2R at a cost of rupees 15 per unit and S2V at a cost of 16 per unit. Okay. So now, the first thing first, okay, I'll just do it simultaneously. What is happening? It's getting locked out. So what we'll do is, we'll first write the verbal formulation, okay? So in the verbal formulation, what are the decision variables here? Can anyone tell me what are the decision variables? Any idea?
Number of units being manufactured at SNN.
No, no. See, you have the transportation costs here, right? So once you have the transportation cost, your objective is to minimize the cost associated with each of these. So minimize 25 into something plus 15. So what is the decision variable then?
Units transported through a route.
Yes, exactly. And like this, you will have several routes, right? You will have from S to B, S to R, S to V, R to V. So let's say my first decision variable is SB, which is quantity to be moved directly from S to B. Similarly, you will have SR, quantity to be moved directly from S to R. Then SV, quantity to be moved directly from S to V. And likewise, all the other variables should be defined. Okay, so you will have NR, NV, NM, RV, RB, VB, VM, BM, and MB. Got it? I'm just not writing it here. Is that clear? All of you?
Yes.
Ma'am, in case of BM and MB, so they would be separate variables or a single variable would do?
Separate variables. BM and MB would be separate variables. Because you don't know. Either it can go from B to M or M to B. It is written in the question, right? So it can be, it has to be separate variables. Got it? Okay. Now we will specify constraints. So what are the constraints? Anyone can tell me what are the constraints?
The storage
Capacity
constraint.
and demand.
The storage. Okay, let's call it plant capacity constraints. Okay, this plant capacity constraints. Okay, for SNN. Then
Demand.
Warehouse.
yes, exactly.
Warehouse
So
storage.
warehouse के लिए let's call it retail capacity constraints. As he also said, demand constraints. And any other constraint?
Route constraint.
What constraint?
The routes, the available route, possible path.
What? How exactly?
I mean, if you have to go from one vertex to the other vertex, you have to follow the given path, or if there are any path only.
No, not exactly. There are some route constraints, but not in the way you are saying it. I mean, it's a very simple problem. Okay, all of you have studied basic things, right? Let's say this is a node. Okay. This is
Two arrows
incoming.
front and
Yeah, so this is outgoing. So let's say agar if I'm having Q1 and Q2 incoming and Q3 and Q4 outgoing. So Q3 and Q4 cannot exceed Q1 plus Q2, right? So it's like Q3 plus Q4 minus Q1 minus Q2 is always has to be 0, right? This is very simple, right? Common sense.
yes, ma'am.
So the fourth thing, if you see here, this is the one where your flow balance has to be maintained. So I'll write this as fourth constraint would be flow balance at retail outlet. Okay. And now I will jump into the mathematical formulation of this, mathematical modeling. So can you tell me what will be the plant capacity constraint? Let's say for plant S. How do I write the capacity constraint for this? Look at this network and tell me.
SBSRSV.
Yeah, what? What SBSRSV? You give me one equation.
Less than 40.
To say no, add it. So for plant S, you will have SR plus SV plus SB. Okay, let's say less than equal to 40. Similarly, for plant N, you will have NR plus NV plus NM less than equal to 65, right? Because these are capacity constraints, so it cannot exceed. Okay, for retail, can anyone tell me for retail? So this is altogether your plant capacity constraint. Next for retail, Divyanshu, can you try it? For R, how will I write?
R should be like
Only
SR
capacity constraint. SR
plus NR
plus NR.
is less than equal to 50.
Absolutely right. SR plus NR has to be less than equal to 50. Same thing for V. It would be SV plus RV plus NV. SV, RV, NV. हाँ, ठीक है. That should be less than equal to 75. Okay.
Ma'am,
Yeah.
This is for warehouse.
This is
ma'am,
for
in
retail.
that
हाँ, warehouse. Yeah.
in that R1 SR plus NR,
हाँ.
we will not minus like RB
No.
plus.
No. That would be
Why,
flow
ma'am?
balance constraint. See, this is retail capacity. Capacity means
Ma'am,
what? Only this much can go in it.
Ma'am, but the capacity like to hold of the warehouse, like at a single point of time, R can only hold that 50 units. So
Yeah.
like if from S there are 15 units coming and 10 are going to B, so like the difference of those will be equal to the supply.
That is taken care of by the flow balance constraint, not by the capacity constraint. Okay. See, it doesn't see your SR and NR now. So NR cannot be, let's say if NR is 40, SR cannot be 20, even if things are going from R to V. Because let's say, what if it is not going? You don't know. What if RV is 0? Your R cannot
So
hold more than 50 units. Okay. So
we will
that is
not
why,
combine these.
no, only flow balance will take care of that. You don't combine. Okay, because if you see, that is like a, what should I say? Once it is coming out of R, okay, it is acting as a demand for V. So
Yes,
when
ma'am.
you take care of the demand, again, demand constraint is something separately that is else. But whenever you go for supply or demand constraints, okay, you don't look for the arrows which change their direction. Supply money, anything which is going in. Demand money or supply means anything which is coming out. Okay, let's say anything which is coming out. Matlab ultimately only 50 units can come out of R. Okay, so that is why anything which is coming out is supply. Demand means anything which is going in that.
Ma'am, but if
Okay.
from R to B, the 10 units will not go. Then
From R to B, that I'm telling you, no, that is taken care of by the flow balance, not by the capacity constraints here. Let's not even jump into demand constraint. Okay, you tell me what will be the flow balance constraint.
total outgoing minus total incoming.
Yeah, exactly. So if I have to write flow balance, that is nothing but SR plus NR is equal to RB plus RM plus RV. Got it? Matlab whatever
Yes, ma'am.
would be coming out of R, that is RB, RM, RV, that again, that can only be less than equal to 50 only. Because you see SR plus NR is already taken care of. Ki wo less than equal to 50 ही it can happen, not beyond that.
So ma'am, in this one on the right hand side, in the flow balance diagram, in the flow balance constraint, so and at RHS 0 will come.
No, not exactly. See, SR plus NR would be some value, let's say 40. So this would also be less than equal to some 40 value.
Okay, ma'am.
Matlab, if you have to write it like this, minus, minus, minus equal to 0.
Got it.
Got it?
Yes, ma'am.
Same thing. For V also, you will write SV plus NV plus RV is equal to VB plus VM. Okay. Now, tell me, how will I write the demand constraint? Let's say for B, right? B is your outlet. For B, how will I write the demand constraint?
And the capacity for B and M are not given in the question.
No, it is not a capacity, no, it is demand. B is your final outlet, na? Sorry, यहाँ पे ना मैंने थोड़ा गलत लिखा था. This shouldn't be retail. Confusing. This
Yes,
is
ma'am.
warehouse. This is your retail demand. So here, why will you have a capacity here? So it is demand.
No, ma'am, I thought that in every retail store also it must have its own capacity.
No, no, no. There is, but this problem is very simple just for your teaching purpose. Okay, so we are not considering all the real life constraints and everything. Retail would always usually have like a demand. Okay, उससे अगर ज़्यादा भी हो, it doesn't matter. Okay, you will have an inventory for that. That inventory constraints makes the problem slightly more complicated. Okay, so any equation which is coming up in your mind for writing this? Ayush, Divyanshu, Sajib, Suma. Suma, I think, has joined very recent.
No, it's fine. Please proceed. Understandable.
Okay, okay. So how will you write the demand constraints?
First for B, we would write SB plus
Hmm.
RB
Hmm.
plus VB
Hmm.
should be
No.
greater.
Plus
MB.
MB.
Yes,
Plus
yes.
something else.
MB also.
MB.
Hmm. Minus BM.
Yes, minus.
Yes.
Ma'am, minus BM.
Ah. Because you don't know. Either it can go out of B or it can come in B as well. Okay. So since this is
Should
the
be
final constraint, no? Since this is the final demand constraint, that is why you have to take care of that. Here, there is nothing called balancing. Here, you cannot write BM is equal to MB because you don't know. So since this is not such a point, this is like the final destination point, here you have to take care of it. Same thing for your M as well. M, how will you write?
RM, VM, NM.
Plus
BM
BM.
minus MB.
Yes, greater than equal to 30. Very good. And finally, your objective function is very straightforward. See, you have all the coefficients here. So it would simply be minimize 25 SB plus 15 SR plus 16 SV plus 18 NR. Okay, like this, whatever are your values. Okay, plus 9 BM, 9 MB. Okay, like this. I have not written the objective function. So then this becomes your entire solution. Yeah.
In retail demand, it should be greater than equal to 75 or less than equal to 75 because
Greater than
our
equal to
overall.
because it's demand,
Okay.
right?
Okay, I
It's
thought it
demand.
was storage capacity. Sorry.
No, it's demand. So you will always try to meet the demand, no matter what. Okay. So can we jump on to the third problem?
Ma'am, 1 second.
Yeah, sure. So please try to solve that earlier problem where we were using R's as the decision variable. Okay, this one. Or if you want it, I can solve it right now also. Do you want me to solve it right now in this class so that I complete these two problems
No, ma'am.
completely? No, it's
No,
fine.
ma'am.
You'll do it as a homework. Okay, so do it and please try to solve it in Lindo or Python. This one, this above problem. Okay, this is needed in order for you to understand whether we are arriving at the same optimal solution. Okay, let's go for the third problem. This is your third problem.
So actually, there was final question was something different in question
Yeah.
number. You
Question
can check
number.
that suppose capacity at warehouse R&D is 50 and 75.
Hmm.
Yes, yes. Suppose the capacity at warehouse R&D is this, then
Hmm.
this is the actual question, right?
No, the question is what set of shipments will meet the demand at minimum cost? This is the question.
Okay, okay.
Yeah. This ultimate line. So that is how we decided that how much shipments
Yes,
to be done from what point to what point to meet the demand at a minimum cost. That is why your objective function is a minimization function.
yes.
Okay.
Thank you.
Yeah. Okay. Yeah. See this problem? I'll give 2 minutes. And I won't solve this problem in this class. I'll solve this problem in the next class, but I just want you to take a snapshot of it and I will tell you how to solve it as well. I will tell you the verbal formulation of this problem and then you try solving it. So next week we'll meet again at 8:30 sharp. Maybe at 8:35 or so we'll start the class. And hopefully these 2 days you did gain some knowledge, if not everything. I hope so. At least for those of you who were present on these 2 days, Goyal sir and Divyangshu.
Yes. So would it be possible
Yes, ma'am.
Would it be possible?
would it be possible for you in the next class to give a demonstration wherein, say, a large number of the decision variables are to be handled? Like, say, if there are 10 number of the plants
Okay,
and that plant is producing, say, 100 number
sure,
of the different products. So
sure.
then how to handle such a situation, I mean, from within the Python implementation?
Sure, sure, sure. I'll do it. I'll do it. I can show it to you right now as well, but then I think 2 hours at a stretch is, I think, a lot to take. So, of
Yes.
course, just remind me in the next class. I mean, next week I'll definitely show you. That is why I was actually telling you. So, in this problem only, right? uh, where did I go? Yeah, here I was telling you, no, that here you don't need to specify decision variables separately. So before I show it to you, I want you to check it out how to generate tuples, something called tuples in Python, and then give the decision variables those automatic names. Okay. Anyway, I'll show it to you. I will show it in my research objective how I did. Okay, so I'll show you my modeling only in order for you to understand. But before I show it to you, it would be slightly easier if you can see that how to generate tuples. Read the documentation of how to define the decision variables when they are too large in number, and then everything stays the same. Like you don't need to define anything separately. But yeah, I'll show it. No problem. Yeah. So
There
yeah, did
is
you take
there
a
any
snapshot? Yeah, tell me.
rather than making some handmade formulation of this LLP problem, so is there any software or any alternative approach that we can do to formulate this problem, this kind of problem?
So, as I was telling you, there are various softwares available. Handmade formulation means I didn't understand. I mean, you ultimately have to
Like
formulate the model on your own.
we have built these charts like tables,
Uh-huh.
but is there any alternative way so that we can upload these questions and then we will get this
Yeah, you
table
have
or
you
charts
have Chat
like
GPT, no, for that.
yes,
But
yes,
then,
yes,
but then, what is the point? Like, if they tell you how to do and everything, you will never really learn or never really
yes, yes.
understand. Yeah.
Okay.
Anyway, everything is available these days. Internet has
Hmm.
had a massive boom, but
So,
yeah, it's
so
always better to yeah.
formulation is the main part. Coding is simple, I think.
Coding is very simple. Formulation is the main part. Coding is very simple. You can learn coding on your own as well. But since
Hmm.
Divyangshu suggested in the earlier class that, okay, I show the Python implementation of the same, so I showed you a Python implementation of a very simple problem at the very beginning of the class today. But yeah, ultimately, because see, everything is available on the internet, all the documentation and everything. You go, you open that, okay, this is the module that I'm going to solve. They will tell you all the commands. In fact, you could see that as I was, solving the model in Google Colab,
Hmm.
automatically the syntaxes, commands, whatever functions I need to specify, everything was coming on its own. So nothing you need to do other than formulating the model and taking care of all the constraints possible. Okay. So did you all take a snapshot of this?
Is it shared also somewhere?
Uh, Not exactly. Like I'm just recording the sessions for you all to go back and then check the recordings in case you are missing out on any. Because I think we have just how many classes? I guess I will be taking only 14 classes, and in 14 classes, like there is a lot to cover. So that is why I'm just recording the session. In case you need the case studies, I mean, I can make it. Some of you had suggested in the earlier class to share these questions. So I just need some time to make a separate PPT for all the questions and then give it. But yeah, yesterday's class, I think I have shared a link in the chat box. So you can refer to it in case you weren't there.
I'm sorry, I missed it. I guess
Yeah, no problem. It's just on every Saturday and Sunday from usually from 8:30 to 10:30, 11ish, because I think it's kind of inhuman to extend it to 12:30, 4 hours of constant classes. You also will get bored. Plus, I also need some time for preparation. So mostly 2.5 hours we are doing. I think in the later stages we might be extending it. But since it's a very beginning class, so yesterday it was just a 2 hour class, and I think today is also almost like 2 hours only, I suppose. So
can you share the link that you were telling about.
yeah,
We
yeah.
had already.
Can you please go to the chat box and check because I've already shared the links. I mean, two links I've shared. One of them, one of today's attendees was not able to click on the first link. So the second link I've shared. Can you just check it in your chat box once? The Teams
Ma'am,
chat
my chat
box.
box is not opening.
Ah, so I can't do anything about it. You, you open Teams again and check. You're joining from RVC, right?
Yes, ma'am.
So there would be I think I have added you all to that Teams group. So can you just open the Teams group and check? Or Ayush, can you share your screen once? Anyway, so just share your screen. Okay, no, open Teams. Okay, no problem. I think I won't be wasting time doing this, but yeah, I would rather share the screen of mine. So, okay. So for the problem that we were doing for this electronics manufacturer problem, can you see my screen? Is my screen visible? I guess yeah. So for the third question, okay, this is my question 3. Can all of you hear me?
Yes, ma'am.
Yes,
Yes,
you are
ma'am.
audible.
Right, right. Okay. So if you see, the first thing first, always read the last line of the problem in order to understand what is your objective. Okay. So here, what is your objective? Formulate the problem of determining the optimal production schedule as an LP problem. Okay. So optimal production schedule of what? You basically want to know how many electronic calculators you need to produce. And if you see how many months are there?
4.
4 months. Now, there are various kind of costs here. One are regular costs, right? Another one is a production cost. Production cost, I mean regular cost. Okay. Another one is an overtime cost. And another one is an inventory carrying cost. So, can anyone tell me what will be the decision variables? First thing first, we'll do the verbal formulation.
Number of calculators produced each month.
Yeah, but produced when? First one would be during regular shift. Okay. So, quantity of product, which in your case is the calculators, to be produced during regular shift in month I, where I ranges from 1, 2, 3 and 4. And the same thing would be, let's say OI, that is quantity of product to be produced during overtime in the ith month. Because see, you have two costs associated. One are regular shift costs, another one is overtime cost. And a third decision variable, can anyone tell me what will be the third decision variable?
Inventory.
Yes, absolutely right. So how much is the inventory? Okay, so II, let's say, would be the inventory at the end of month I, where your I is again 1, 2, 3 and 4. Okay, what are the constraints?
Overtime production and regular shift production.
Very good. What is the associated statement in the paragraph?
It is limited to
which
100 units and 60 units.
Absolutely right. So you will have regular shift capacity constraint. You will have overtime capacity constraint. What else?
Inventory should not be there at the end of month 4.
Okay, so ending inventory. What else? Anything
Production per
else?
month. Demand per month,
Yes,
like order in
very
hand.
good. Exactly, exactly. So that is demand constraint. But here there will be a slight catch. Okay. Now, basically, this is your, okay, before explaining this, tell me what will be your objective function?
Maximizing
Maximizing what? Where can you see anything about maximizing?
quantity of the calculators.
No?
Quantity of
How will you know? How will you specify your decision variables like that? You can't. You have no costs associated
Minimizing
with
the
it.
cost.
Exactly.
Minimizing the cost.
Simple. Exactly. Simple. Minimizing total cost, which is nothing but your regular shift production costs plus overtime production cost plus inventory cost. That's it. And non-negativity. That is, all decision variables have to be greater than equal to 0. Now, before I leave, one thing that I want to tell you about this demand constraint, there is a slight change. For example, if you see in the last problem, what were you doing at the retail outlets? You were trying to maintain the flow balance, right? Similarly, here also in the demand constraint, there is a simple flow balance like situation. What is it? That is nothing but, let's say you have some initial inventory. Okay. Then you produce something. That would be equal to what? Okay, let me say it that way. Let's say you had some initial inventory 0. You had nothing in store. Then you produced something. Okay. Then you sold it minus demand. It might happen that your produced quantity is more than your demand. Then in that case, what are you left with?
Inventory.
What is this equal to? So that is ending inventory. So for this demand constraint, you will have to formulate 4 such constraints for 4 months. Okay, this is the only thing that you have to do. So try this problem out in the next class. Okay, like before the next class, of course, and then we will discuss more about it. Okay. So yeah, that's it from my end today. That's all for today's class. Thank you so much. We'll meet next week again.
Yeah, thank you so much. Very, very useful class. Bye.
Yeah, thank you. Bye bye.
Thanks.
Thank you, ma'am.
Yeah, thank you. Thank you.